projects. In this video, we are going to explain about a project titled Ranking-Based Deep Hashing Network for Image Retrieval. In the modern era, the rapid proliferation of digital imagery has sparked an urgent demand for streamlined image retrieval system. Conventional approaches reliant on textual tags or metadata are grappling to cope with the exponentially expanding image repository. In response, content-based image retrieval techniques have emerged as a solution. Among these, deep hashing networks have emerged as a powerful strategy for condensing the complex image data into the concise binary code. Facilitating the shift and scalable image retrieval process, this project introduced an innovative concept of the ranking-based deep hashing network. This novel approach is meticulously designed to enhance the precision and efficiency of image retrieval endeavor, aligning with the contemporary need for agile and accurate retrieval from vast image collection. The primary aim of this study is to create a robust and efficient image retrieval system using the advanced deep hashing technique. This research is driven by a specific objective. Firstly, crafting a deep learning network that can adaptively transform the complex high-dimensional image attribute into the concise binary code. The network process lies in the capacity to retain the intrinsic semantic essence of images while minimizing the code length. Secondly, the introducing a novel approach called ranking-based learning, which optimizes the deep hashing network. This methodology hinges on recognizing the relative similarity among the images and enforcing an order that enhances retrieval performance. Lastly, this project involves comprehensive experimentation and the comparison with prevailing image retrieval method on the benchmark dataset. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB and above, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this, we need to import the essential libraries and packages to facilitate the data manipulation, analysis, and model building for the image retrieval. And the next one is exploring the dataset. The dataset containing the images for the retrieval task is thoroughly explored to understand its structure, dimension, and the attribute. And the next one is image processing. Raw images are processed to ensure the uniformity and suitability for the model. This involves the resizing images, normalizing the pixel value, and converting the images to arrays. And the next one is data augmentation. Data augmentation techniques are applied to increase the diversity of the training dataset. This involves the technique like rotation, flipping, and adding the noise to enhance the model generalization. And the next one is building the model. Here various models are built. The first one is RDHN. Ranking-based deep hashing network is an advanced model architecture that incorporates the element of convolutional neural network along with the discriminator and generator, inspired by the generative adversarial network. The generator creates the compressed representation of input image, and the discriminator aims to improve this representation by distinguishing between the real and generated image. This model aims to create the efficient and accurate binary code that represents the image for the improved retrieval performance. And the next one is CNN, with using of Torch ResNet. Here, a convolutional neural network utilizing the ResNet architecture implemented using the PyTorch framework. ResNet is characterized by residual blocks that mitigate the vanishing gradient issue, enabling the training of very deep networks. The CNN with ResNet architecture excels in the feature extraction from images, capturing the intricate visual pattern. In the context of the project, it aids in encoding the image into effective binary codes. And the next one is CNN Torch VGG. The convolutional neural network using the VGG visual geometry group architecture implemented in the PyTorch. It is known for its simplicity, featuring deep layers with a small convolutional filter. This model with VGG architecture effectively extracts the hierarchical feature from the images, contributing to the accurate image representation for the retrieval. And the next step is user gives the input. Here we build the Flask, a web framework where the user provides the input in the form of an image related to the retrieval task. And the next one is the given input is pre-processed for prediction. The input provided by the user undergoes the pre-processing similar to what the training data received. This ensures the compatibility with the trained model. And the next one is trained model is used for the prediction. The pre-processed user input is fed into the trained model to predict the most relevant image from the dataset for the given query. And the next one is final outcome is displayed. The predicted images are consolidated and presented as a final outcome, this be in the form of the gallery of relevant images based on the user input and chosen model. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The Cipher 10 folder containing of the training and val folders containing of various folders with it consisting of various images within it. And the data folder containing of the images within it. And the generated folder containing of the generated image from it. And the sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the CSS, fonts, images, JavaScript files within it, and the template folder containing of the HTML documents. It typically include of home, retrieval, sign in, sign up, upload, but HTML documents within it, and the APIs and py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the Cipher 10 and Cipher 20 is IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to open the code Anaconda prompt. Here we need to write the command cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. Here it will redirect it to this page containing of some information and the title of the project. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm clicking on the sign in button. Here it will redirect to the sign in page containing of username and password, and we need to fill those details and then click on the login button. Here it will redirect it to this page containing of the choose file, upload, and retrieval buttons. And then click on choose file button. Here it will redirect it to this folder containing of various images within it. I'm selecting one image and then click on open button and then click on the upload button. We can see that image is uploaded successfully and then click on the retrieval button. By this it will move to the result page which it can retrieve the images which are of aeroplanes. In this way we can retrieve the images by using the steep hashing network. And in conclusion, the presented novel ranking-based deep hashing network for image retrieval, our approach aimed to address the challenges of efficiently encoding the high-dimensional image data into compact binary code while preserving the semantic information for accurate retrieval. By introducing a ranked-based learning strategy, we successfully improved the retrieval order, leading to the enhanced retrieval performance.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.